Hi, Professor. I would like to thank you again for letting me present the demo and excusing me for actually not being there for the demo. So I'll get right into it. So the app that I'm developing is called Easy Find, and Easy Find is targeting at indoor navigation. So a more precise indoor navigation, because GPS gives you a precision of like around 30 meters. So when you're indoors, let's say you are inside a museum or you're inside the Met Stadium or even a supermarket, so a precision of 30 meters is not good enough. So to achieve this, I'm going to be using the technology of iBeacon, so which is a Bluetooth low energy signal transmitter. And using this, I'll try to triangulate my position and navigate around an indoor space. So basically, the Bluetooth low energy signals, they have a UI ID which have some attributes associated with it and some characteristics. So based on the UI ID, we can recognize some of the services that it provides, that the beacon provides, and the characteristics of that. So like you can actually preset in a beacon its location. So if I put a beacon over here and I fix it, then I can put a preset a location over there, and when I receive the beacon on my phone and I connect to it via Bluetooth, I will know what's the location of the beacon. So if I'm able to do this with 3 beacons, I'll know all of their location and I will be able to triangulate my position. And as I move, if I continuously refresh, I should be able to emulate what the GPS does with satellites. So except in this case, the beacons act as satellites. So the advantage of the using iBeacons is that it's Bluetooth low energy. As the name suggests, it is low energy, so it consumes far less energy. We don't need Wi-Fi to connect, and it requires some amount of authorization, so there's some amount of privacy involved. So uh, now, to build this app, I use the Google's Beacon Proximity API. So the Beacon Proximity API lets me connect to a beacon transmitter and get all the necessary information I need from the beacon, like the UI ID, the location, the device name, and such. So the only limitation that this puts on me is when I try to access any of these, it says that the beacon is not registered. So the reason being that using this API requires me to register the beacons online in order for me to preset the location. So using just the BLE code on the Android and the Android website, I can just connect to the beacon and get the information from it. But I'm not able to. But in order to make good use of it, I'm not able to do anything. I'm not able to preset the location into it because I've not registered the beacon. So I try to go for a estimation like using the RSSI value of the transmission power, but this is highly inaccurate considering that even if I just cover the receiver on my phone, it would receive a far weaker signal, and it would estimate that the beacon is far away, and the location will go horribly wrong. So the beacons I've used is like an iBeacon transmitter, and mainly the Estimote app, which transmits an Eddystone beacon. And so I'll just run the app on my phone. So yeah, so this requires me to sign in with my Google account because I'm using the Google's proximity API. So now I have my transmitting. So when I hit scan, I'm able to view the beacon, and I have logged some of its things here. So we can see it's the fragment details. We can see the RSSI value, its transmission power, and the other details here, which I'm able to access. But when I try to bypass the registration thing on the code, well, the app starts crashing.
So
And
yeah, so when I try to access the details on the beacon, I try to bypass the registration thing. So for initially it used to show me to go online and register, which I tried to do with a free trial version, but it did not work. So I try to remove that part entirely, and it throws some other error. I have not been able to figure this out with whatever time I had. So basically, the whole idea is to do triangulation. So had I had the latitude and longitude values, I would go about doing triangulation like you would do in the GPS. What we would do is we would take the location of beacon 1, beacon 2, and beacon 3, and we try to get a sphere of each and try to find an intersection, and that is where the three spheres intersect is approximately our location. So the more number of beacons we use to calculate this, the more accurate our location gets. So the idea doesn't change, and the only difference is if I don't have a presetted location in the beacon, if I try to estimate the distance manually, there's going to be a huge error, and the accuracy will not be there. That defeats the purpose of making this app in the first place, which was to get highly accurate. Otherwise, you could have just used a GPS. So like I showed, I try to log those values. It's also there in the PPT which I will be sending you. So the main issue was I was not able to preset the location in the beacon, and when I tried to bypass the registration, the app started breaking. So I was just able to access the UID and other characteristic features of the beacon, but I wasn't able to do anything much after. So future work would definitely be trying to be able to get around this and build the code more and see what happens if we are able to locate the beacon precisely. And yeah, that's about it. Thank you so much.